Hey there, welcome back to CMTEQ channel. In this tutorial 2 of the overhead line steady state operation, we're going to be discussing how to draw this phasor diagram of an inductive load for a short transmission line. So if you want to know how to draw this phasor diagram and get a solid understanding of how each phasor is related to each other here, please stay tuned until the end of this tutorial. In the previous tutorial, we were discussing about the resistive load operation of a transmission line. If you want to know the phasor diagram operation of a resistive load transmission line, please watch tutorial 1. Great. So as we know from tutorial 1 that for short transmission line equivalent circuit diagram like this, the capacitive reactance is negligible. We only focus on the resistive and reactance of the line to basically calculate the voltage drop. So that is given by Z is R plus JXL. Please watch tutorial 1 where we talk in great detail about this equivalent circuit diagram. Great. So to better understand the phasor diagram and draw it accurately for this short transmission line, you need to understand the characteristics of the load. This is why we did for a resistive load where the angle was 0 degree, right? The angle of the current was 0 degrees, so there was no phase angle. Okay, but now in inductive load the situation will change because the load is now purely inductive. Okay, now because the load is purely inductive, the current will then lag the voltage, right? Now this is the VREC, the receiving end voltage, so the current will lag the receiving end voltage at an angle which will be a negative angle. Now these lags is basically introduced because of the inductance, the inductive reactance that opposes the changes in current. So that will basically what will give us a negative angle for the current. Now that is a key point you need to understand so that you can start drawing your phasor diagram. Now let's go ahead and start drawing this phasor diagram. Great. So first you need your origin, the starting point of everything. So this is our origin here. Then you need to draw the reference voltage, which is VREC at 0 degree angle. And we draw our VREC. Okay. Then because we understand that this is an inductive load and the current lags the voltage at a negative angle, then we can calculate that angle. Okay, once we calculate that angle, we can then plot that angle somewhere here and get the magnitude of the phasor, the current phasor. That way we can then have the phasor of the current drawn at a particular angle. So this here is then the negative angle of the current that lags the voltage, and thus current IL is equal to the I send as we discussed on tutorial 1, because it is a series circuit, so the input current is the same as the output current here, but there is an angle difference between the two because there is an angle that is introduced in the load current. Great. Now the next element for our phasor here, basically the next phasor is the voltage drop across the transmission line, or VZ. Okay, now the same applies with the resistive load here. We know that VR here will be in phase with the current. Okay, so VR will be in phase with the current. We can then draw our VR phasor just like that. But now because VL is basically leading this VR here by 90 degree, it's important to note that this VL here, the voltage across this inductance here, that VL is not leading VREC by 90 degree. It is leading VR, the voltage across the transmission line resistance, by 90 degrees. So that means we can draw our VL 90 degree out of phase with VR. And by the way, if you find this tutorial useful, please make sure you give a thumbs up and subscribe to CMTEQ channel. That will be highly appreciated. Thank you so much for the support. And if you are studying power system and you'd like to receive assistance from CMTEQ channel, you are more than welcome to join CMTEQ channel membership, and that way you can pose your assignment related question or any other topic you'd like CMTEQ channel to personally cover. So feel free to go ahead and join the channel membership. Great. Now that we know the phasor of VL and we've also plotted the phasor of VR, we can very much easily make an algebraic sum of these two phasor here, okay, to basically make a projection of our VZ. But equally so, if we know the value of VR and the value of VL, we can easily calculate the value of VZ, which is angle, and plot the VZ phasor in reference with the V receiving end, because it is important to note that VZ is the voltage drop on the transmission line that is in reference to the receiving end voltage. So which means the angle of VZ here must be reference to the V reg. So we can go ahead and make a projection of our VZ. That will be the voltage drop across the transmission line, and the angle theta Z can then be reference from the Vreg phasor. Great. Now to complete our phasor diagram for inductive load here, we only need to draw the sending end voltage, V sending. Now this is here is the power plant, basically our substation or the generating substation, where we're generating the voltage at 132 kilovolt, and we want to send it along the transmission line using these pylon here, okay, and we encounter a voltage drop across the transmission line because of the reactive element of the cable and the resistive element of the cable. Okay, so now we need to know how much will be our V sending in relation to the V receiving, because remember, V receiving before we close a circuit breaker here is basically equal to V sending, okay? But as soon as we close a circuit breaker, there is going to be a current flow, then there will be a voltage drop, and V receiving will be less than V sending. So just like we did on the resistive load tutorial, to draw the phasor diagram of V sending, we have to make a projection of the VZ, because remember, what's missing in this V receiving end here is VZ. So V sending end is the algebraic sum of V receiving, okay, plus VZ. That will be the V sending voltage, V drop plus V receiving. So in order to draw it in a phasor diagram, we make a projection of this phasor here, okay? We project it at the top of V receiving end here, and based on this projection, we can then go ahead and plot the V sending phasor from the reference to the top of this projection here. That will then be the V sending end voltage, okay? So the V sending end voltage will have an angle theta sending. This is going to be theta sending in reference to the receiving end voltage, and between the load current phasor and the sending end voltage phasor, we're going to have an angle there, and this is basically going to be the total angle between theta send, and that's basically going to be theta L plus the sending end angle. So this is it, guys, for this tutorial on how to draw a phasor diagram for an inductive load in a short transmission line. So if you found this tutorial useful, please make sure you give it a thumbs up and subscribe to my channel. That will be highly appreciated. If you have a comment, please drop your comment in the comment section below. Until next time, cheers.